Welcome back to Maths with Mrs. J. It's time for another challenge question, and this time I wanted to do something a little bit different. It's a little bit geometrical rather than just algebra, which I normally tend to pick. So we're imagining that we have three cubes that are stacked in a corner, and they're stacked in such a way that two of their faces are aligned. So we could imagine this line coming down here is in the corner of a room, and we've stacked them up in that way. We're imagining that we've had a line drawn from the bottom near corner of that biggest cube all the way to the top far corner of that smallest cube. Now the cubes have side length 3 centimetres, 2 centimetres and 1 centimetre. We are asked to find out what length of this line passes through that middle block. It sounds very complicated. Thankfully, it's nowhere near as complicated to work out as you might first think. The first thing I would do in this situation is I would draw a line across the diagonal of the bottom cube. This forms for us a right-angled triangle. If you can picture it, this is horizontal, this is vertical, so obviously it's a right-angled triangle. We should be able to work with that right-angled triangle in order to find out that length. Before we do that, we just need to work out what the length of this diagonal is. This is quite an easy situation. We just have a square with side length 3 centimetres. This is a right angle, of course. So the diagonal squared will be 3 squared plus 3 squared. So the diagonal will be 3 root 2. Let me now draw for you this big triangle. So what we've actually got, and I'll keep colour coding just for now anyway. So we've got our 3 root 2 coming across the bottom there. Then we've got 3 coming here. We've got 2 above that and 1 above that. And our red line comes all the way down here. And we know that this is a right-angled triangle because, well, this is horizontal and this is vertical, and it's safe to assume that between horizontal and vertical you have a right angle. What I'm going to now do is I'm now going to divide this up into embedded triangles. If we have a look here, if we were to rule across from here, that's across the top of the bottom cube, and this is across the top of the middle cube. Now what we actually have here are similar triangles. Why are they similar triangles? Well, pretty obviously, this is a right angle, this is a right angle, and this is a right angle. So they all have a right angle, and they all contain this top angle up here. All right, the little triangle has that angle, this medium triangle has that angle, and the big triangle has that angle. Because they have two angles that are the same, the third angle has to be the same. That's just the way it works, sum of angles in a triangle. So these three triangles are similar. Because of your angle, angle, angle rule. Okay, what do we know about our side lengths? Well, we know that we just worked out that this was 3 root 2. We know that this is 3, this is 2, and this is 1. So this total length here will be 6. Just added up those values there. We can work out the total length of this by using Pythagoras again. So if we call this maybe capital D, so capital D squared will be 6 squared plus 3 root 2 squared, okay, which is 36 plus 18, which is 54. So D is going to be 3 root 6. Now, because these are similar triangles, their sides will be in the same ratios. So the length, this is the length that we're actually wanting, this length here. Okay. We know that the ratios are going to be the same. 1:2 3 along here as well. So if we were to divide this 3√6 up into an x, a 2x, and a 3x, they've got to be in that ratio. That will be our total. So 6x is our 3√6, but this is actually what we want, isn't it? So we've got 6x is 3√6, and we want 2x's, which is our √6 centimetres. That is our answer to our question. Okay, using the equivalent ratios of our sides. And there you have it. So √6 centimetres is the answer to that question. You can see some cool things online where they will actually rotate this diagram and you can see it from all angles, which is kind of cool. Unfortunately, I don't know how to do that on my computer. But yeah, this question ended up being a lot easier than it first seemed.